what I have here on the computer is a code. It's what we worked on before, where we worked with the digital inputs and outputs. Actually, not the digital, the analog. These are the analog. It says analog. But again, what we've done here with this, just to kind of catch you up, is we have hooked up a potentiometer to pin A0, and we are getting that value, and we're also mapping it somewhere else. And then we have an LED hooked up to pin number 8, and basically we are just we're utilizing that to kind of combine a few different things. So we're beginning the serial communication, and then we're saying that the LED is an output. In the loop, we're just reading that value from the potentiometer, and then we are mapping it to something else. We're then sending this out the serial port so we can see it, and we're also using that value to adjust the delay time between turning on and off the potentiometer. So let me get my wire here so that way we can at least see the serial port. So let me plug that into my Arduino. I know you can't see it. Don't worry, you'll see it in just a moment. But I've got here, if we go to Tools, we make sure that we have the Arduino Uno. It's plugged into COM3. That's great. So let's open the serial monitor. And now it's going to talk. So we can see some of that didn't quite work out in terms of spacing. So I'm going to actually just remove that, and I'll put it down here, and we'll re-upload the sketch. That way it just doesn't look disgusting every single time. So I'll go back and we'll open up that serial monitor, and we should see that the potentiometer value is there. We can see the total percentage. And as I adjust it, it speeds up, and as I slow it down, it goes back down. Full disclosure, I don't actually have a potentiometer set up at the moment. It's still the photoresistor that I looked at the very end of last video. But you can see it's responding to the amount of light that it can touch. As more light enters the system, the delay increases. That's what we've got going on. But the reason I wanted to start with this is because from this point, it's a very relatively easy thing to do to swap to the pulse width modulation. And I've used that word a bit before. So let me actually pull up the textbook here and pull up a diagram. I think this will be very helpful for you all. So again, everything I'm talking about is here in the textbook section. You'll notice that pulse width modulation is still in the same section as analog, because it's technically analog, but it's also it's like in the middle, a combination of both of them. So basically what's happening, what we're going to be doing, is causing the light to blink on and off, just like this. And I'm going to cover it up again, but I'll leave it for a second, so it may blink a little fast. I am warning you now, photosensitivity, this blink speed will increase. That's about as good as I can get it with this particular sensor on, but I've got one up here in a video that does the same thing, but with the potentiometer. So you can explore that on your own if you want. But if you remember from before, in the digital I/O, an LED is a digital component. It only has two states, on or off. There are no other options. But we can mimic those other options by taking our LED. That's not an LED. By taking our LED, and we can turn it on and off extremely fast. This is faster than the human eye can tell. It's happening extremely fast. But because it's happening too fast for us to be able to tell a difference, we can use that to manipulate its perceived brightness. So again, we're going to be doing this same thing, only much, much, much faster. And in order to kind of talk about this, we have pulse width modulation. So if you think about every time we turn on the electricity is a pulse of a pulse of power going through. And then if you look at it over time, the percentage that electricity was on is the duty cycle. That's the width of this pulse. If we look at if this is time horizontally, so by having it on for 75% of the time, it'll average out, and through our brain, kind of smearing things together that's too fast for it to interpret, it will look as if it is 75% of the volume, so, or the brightness, because it's on, but it's only on 75% of the time. It kind of lights up that way. So I've got the tutorial for what I'm going to do all listed out here, but I'm going to just walk you through it. But so if you wanted to look through this, there's some more info. So in terms of the code is really, really simple. So I'm going to get rid of actually, I'm going to first file save as. We'll save it as a Arduino. There we go. Okay, so there's that. So now that I've not overridden my old stuff, I'm going to delete this part with the delay. We don't need that. I'll keep this bit right here. But there's a few things we can do. There's a reason I've mapped this automatically. We can find mapping that will be pretty helpful. But we'll map it to a few different ranges, actually. So let's go int RGB pot. I'll leave it like that, equals 0. And then basically I'm just going to map this to a different range so we can see some of the differences. So 0 to... All right, there we go. And then... All right, so I've got this listed a few different ways because it's going to be the same incoming value, but we're going to map it to a few different things. We can see a total percentage of the maximum brightness, as well as if we were to map it to that RGB value, which is a refresher. RGB goes between 0 and 255 on the far ends of it. So that's why I've mapped this twice, so we can see what works better or not for our code later on. So all we have to do now is do some tweaking. So right now our LED is connected to pin number 8. Normally I would make some adjustments with this in the circuit part of the video, but I'll mention it now. Whenever you want to do the pulse width modulation on Arduino, you need to look at your digital pins. Okay, and on the side it will say PWM with a little squiggly mark. So any of these pins that have the little squiggly mark before their number are the ones that you can use for this. So on the Arduino Uno, that is pin number 3, 5, 6, 9, 10, and 11. Any other ones, this will not work. It has to be with the little squiggly output. So I'm going to change this LED to be pin number 10 on mine. And then we'll have to change that in the code to be a pulse width pin. Other than that, that's pretty much the only thing we have to change. The only thing that's different is that now in order to send out that electricity, we have to say analog write. And again, this is a function for writing this pulse width modulation data. It's the only way we analog write, and it has to be one of the pulse width pins. Otherwise it won't work. So we'll write to the LED pin, and we'll send the mapped pot value out there. So let's just send it. It is done uploading. Cool. So let's look at it with the numbers first, and then I'll break down the circuit bits in the other video. So if we open up that serial monitor again, we should get 3 things. That's happening extremely fast. So I'm going to make it stop auto scrolling, but we can see that we've got that pot value, we've got that percentage, and it's mapped to that RGB. Just generally looking, we can see, because I've still got the wrong sensor hooked up, it's not super accurate, but as I cover this, that LED dims, and actually I can get it really dim, and then it'll brighten up when it's exposed to light. So we can use that to control the perceived brightness. Again, what is happening is we are turning it on and off a lot, way faster than we can see. We are just perceiving it as being 75% on. In fact, if I, again, opened up that serial monitor, again, this time I'm sending out the RGB value. So it's an RGB, think of 72. If I close it, brighten it, you may get different brightness results, but I'll turn back on auto scroll and kind of do this a few times. And then we'll turn it off, and you can see that this is changing those values as we go along to get brighter or dimmer lights. So again, we're just changing how fast it is blinking. You can stare at it. It's not going to hurt your eyes or anything more than normal, but it is just turning off and on way too fast for any human to be able to see. If we had a super, super, super high-speed camera, we could probably slow it down enough to be able to perceive it. But the whole point is that because it is too bright to be able to tell a difference, we, as humans, are seeing it as a single brightness. So pretty much anytime you see an LED that can change its brightness, that this to some degree is what is happening. Again, I'm speaking very broadly, but generally speaking, this is how you can control the brightness of an LED. Okay, so this is a bit of a test. My other microphone had broken, so I'm just using the built-in phone microphone for this one. So that's why it sounds different. So I've got on the screen here the circuit that will go along with the Pulse Width Modulation portion of this course. So I'm going to just go ahead and get rid of this button that we don't actually need. It's left over from another thing. And I'm going to go on and connect my Arduino to power. That has all been plugged in. So actually, this is already set up because I was doing some testing. Let me hide that just to make sure that it's actually working how I intended it to. Okay, it is. So let's do some stuff. Let's actually just disconnect all the bits, and we'll build this from start. Okay, for the most part. Okay, so I've got my breadboard here. Again, we're going to be connecting both sides to power and ground. That's just going to be a default on all of mine. As well as, at some point, we're going to have to connect to the positive and the negative, so I just left those wires in there. I've got the LED that I was using before. This one's a little bent up on the leads, but we'll get the idea across. So what I'm going to do is I'm going to go ahead and just plug this in wherever we want to go. And then it's got to go through the 220 ohm resistor. So I'm going to connect that to the negative end. Just double checking my ends. There, and that will go to ground, just like so. The positive end is going to connect, to the positive end of the LED, and just slide that right in there. And that will go to pin number 10 on the Arduino. If you remember that from the code portion, pin number 10 on the Arduino. So that is plugged in right there. That's the first part, and again, we're just going to be turning this off and on, actually incredibly fast, but we'll go from there. So what I'll do is I'll connect the whole Arduino to power just so we can see that, yes, there is actually power going through the system. So power and ground. You can see that now it's starting to light up, but it's a little random. And if I just connected it directly to the power, it would just be on all the time. So we're going to work with this a bit. So let me just plug that back in. I need to get some new jumper wires. These have been used a bit. And we'll plug this one back into pin number... Actually, I'll leave that off for a second. Next, I've got the potentiometer. I'm not going to break down exactly what it is, how it works. I did that a bit more with the analog video. But just the short version is you turn the knob, the resistor value of the component changes. We connect the outside to positive and ground. It doesn't matter which one is which, so you can flip it around to change the rotation direction. But the middle one is going to be the one that we measure the electricity coming off of. So I'm going to plug this in. I've already got the positive and negative right here already lined up. But if not, you would have to do that. So I'm going to plug that right there and then take my my wire that connects to pin A0 on the Arduino. You can kind of see it there, A0. That yellow one. And I'm going to connect it to the middle pin of the potentiometer. And I think I've got that in there correctly. So all that's left is now reconnect that LED back to pin number 10 on the board. So we now have a light that is on, kind of. What is happening is, if you remember back from when we looked at the numerical value of the LED, we are turning it on and off incredibly fast, faster than the human eye can see. And the way the code is working is it's looking at the voltage coming in from this potentiometer, and as that decreases, we are decreasing the amount of time that the light spins on versus what we spend it as off. We're decreasing that duty cycle, which makes the light seem dimmer. Again, so we're technically turning it on and off, but it's happening so fast that the human brain can't perceive it, and that is just how we see it instead, as the LED changing in brightness as this turns. There may be a point where it only gets so bright. That's fine. That's just limitations of the Arduino and the resistors and the LED. So you play around and find different values, but there may be a point where it seems to kind of max out. You could also map the values in the code a little bit different, but this way we can decide on the brightness of that light, and we can have it respond to different scenarios. If you remember before, I had a photoresistor hooked up, but this time I'm going to work with a pressure sensor instead, just to mix it up. So instead of the potentiometer here, I'm going to pull that out, and I'm going to, right now the LED is going a bit nuts just because the circuit isn't complete. But I am going to instead add in that second resistor and the get over there, and there we are, and the kind of little breakout. So now we should just be able to squeeze this little circle and see the light get brighter. So let's try it. It's kind of hard to see exactly how hard I'm squeezing. And remember, again, it's not necessarily linear, so having very subtle touches are doing a lot at the beginning, but then squeezing between here and squeezing much harder doesn't get as drastic of a change. So again, this has some really cool applications of it, but with these particular components, it may seem a little limited. So I would recommend experimenting and seeing what sensors work better with different situations. I've already you mentioned a bit about the limitations of the photoresistors, but this is another fun one. Now that this is set up, I can just put this in here. And we can see that as I cover it, it gets a lot dimmer. There's still a lot of light in this room, but as we open it up, it gets brighter. And again, you can play around with whatever sensors you may have in your kit. They usually come with a handful of them. You can play around with different components instead of LEDs. Sometimes they'll have other components like motors and things that will work. I'm actually going to try on the fly this particular one right here. If I can get the pins in the hole. Get in there. Oh, gosh. Then you go to ground, and then you go to, what is this? A0, I believe. So let's just make my life a little easier, and we'll just jump it from over there. So we should see maybe. I don't know, but just we can experiment. This is a distance sensor, so it's supposed to be able to tell the distance between things in front of it and adjust the brightness. Maybe I'm missing a part. I just kind of tried this on the fly, so I don't know what if I did it like this with that built-in resistor. Would that maybe work if I move it closer to the ground? There's some fluctuation there. I would need to experiment more with this. I just tried it on the fly because that was the first component that I hadn't used already that I grabbed out of my box. But again, you can explore, try different things, see what works really cool. Again, the creating of the pulse width modulation circuits are essentially identical to the analog circuits, only we have to specifically use the pulse width modulation pins on the board. And if I was to rotate this and kind of bring it up, let's see if I can adjust any of that focus, maybe. But you'll notice that this is the wrong side of the board, first of all. But you'll notice, and yes, I know it's upside down, my cable is only so long, but some of them have these little squiggly marks next to the board number. And this will appear, depending on your board, sometimes on the headers, but definitely printed on the board itself. But any of these with the little squiggly marks next to them, those are the ones capable of doing pulse width modulation. Anything else, this won't work on. It has to be one of these little squiggly marked pins in order to use the pulse width. And that's why I put mine on pin number 10. All right, so that's just about it. I'm going to end it here and combine this with the code video in order to have one cohesive lesson left. There is one more lesson to go through, and that's a bit more of a complicated one. So I'm going to try to get these three all ready and up to go in their completed version, and then I will work on that longer one, but that may be a winter break kind of project. We will see. I need to make sure all of my code is updated and things of that nature. So that'll be where I end it for today. Thank you all, and I will see you all the next time that I see you. Bye.